Now let's take a look at both of these guys a bit closely, and when should you use which, when should you write your own VEX code, or when should you create an attribute VOP node and lay down nodes. First, let's go inside of the attribute VOP node. Here I have newly created my attribute VOP node and right now it is empty. And first let's create an A example, and I'm going to create an A noise based attribute, and we will use this noise attribute to drive our extrusion. So first maybe let's go on to the sphere, and onto this sphere I'm going to change this mesh type to polygons, sorry, not the primitive, polygons, and that will just triangulate our sphere. And I can change the divisions by adjusting the frequency. By adjusting the frequency I can create more or less these triangles to add more resolution, and that will just create a more interesting shape for the extrusion. So now let's go inside the attribute VOP node and let's dive inside, and in here let's type noise. And if you type noise in here, and here as you can see we have lot of these types of noise, so you can create any type of noise. We have this cellular noise, flow noise, periodic, and all of these noises. So I'm going to just add an anti-alias noise in here. So let's add this, and in here we have this noise node, and we have some parameters. We have the signature. Right now it says 3D input and 1D noise. So what that means, it means that we need to input the position as a 3D input for sampling the noise. It required the position at which position this node should sample the noise, and it will output an A1 value. And here as you can see, if I hover over to this output, these are the outputs, and here we have this noise and it is an A float, so it has an A1 value. That is why it's a 1D noise. I can change this to 3D input and 3D noise. Let's click on it, and now here as you can see we have the anti-alias noise, but now it is a vector, so it has 3 components, X, Y, and Z. So let's change this to 3D input and 1D noise. And for sampling the noise it required the position. We are going to put the point position. So if you go back onto the sphere, and here as you can see we have these points, and these points have their position in the 3D space, and these positions are stored in attribute name called P, that is for the position. Now let's import this P inside of this our attribute VOP node. And to actually import this, all of these attributes, so up here, if you have any type of attribute and you want to import, I can go inside the attribute VOP node and I can add a bind node. By using the bind node I can import the attribute. So let's add this, and onto the bind node let me bring up the parameter, and in here we just need to type the name of the attribute. So the name that I want to import is called the P, capital P. So we need to just type the name of the attribute and the data type. So P is a vector, so let's change this to vector, and now I can just plug this in here onto the position, and now the noise know at which position it should sample the noise, and it will output a noise value. And we can actually visualize this noise as a color. I'm going to write this into a color diffuse attribute CD, because as you know that CD is an attribute that Houdini understands to set the color of these points. So I'm going to create a bind export node in here. Let's add this, and I'm going to rename the attribute to CD, capital C and lowercase t, and it is a vector. So I'm going to change this to vector, and I'm going to just plug this in here. And here as you can see our sphere color has been changed to a darker value. And let me hide my point display, and here we can start to see some pattern. So let's go into the anti-alias noise, and in here let's play around with these settings. So at first we have the 3D frequency. By adjusting the frequency we can create high or low frequency noise. And in here we have the offset. We can play around with the offset. We have the noise offset around the X and the Y and the Z, and we have the amplitude. If we increase the amplitude, here as you can see our color is getting brighter, which means that our amplitude is high. And I can play around with this 3D frequency to play around with this noise pattern. And right now this noise is looking very coarse, and that is because we are applying the noise onto our points. This resolution directly affects how many points do we have. If we go back, and if I were to create more of these points, I can add the more frequency. And here as you can see, as I am starting to increase the number of points, my noise is getting sharper and sharper because we have a lot more points to sample the noise and also apply our noise onto these points. Because we are applying this as an ACD, and the more points we have, basically the more resolution we will get. So let me hide this, and here as you can see we have the noise pattern. And let me go back onto the sphere, and here as you can see right now we have the CD as an a point attribute. If I press and hold the middle mouse button, here as you can see we have 2-point attribute CD, but I want to drive the extrusion based on this noise. And if I type the poly extrude node, as you know that we have this attribute, this Z scale attribute, and this poly extrude node expect them on the primitive level to extrude these primitives. So what we can do, we can go into the attribute VOP node. I can change this run over method to primitive, and now here you can see our noise has been applied onto the primitive level because we have the CD, if I press and hold the middle mouse button, as a primitive attribute. So now we are coloring our primitives and not the points. That is why we have this noise pattern different. Or we also have a node for promoting these attribute. So let's say if I were to change these 2 points, and if I middle mouse button, here we have the point as an CD attribute. I can add after that attribute promote node. As we have the group promote node, we also have the node for the attribute promotion. Let's connect this, and let me view the attribute promote node. And in here we need to define the name of the attribute. So let's click on it, and here we have color CD. So let's add this, and the original class is the points, that is correct. And the new class, I want to change this to primitive. And here as you can see, now we have the attributes promoted onto primitive level. If I press and hold the middle mouse button, and here as you can see we have the primitive attribute on the primitive level, CD attribute on primitive level. You can also use the attribute promote node as well. Let me remove this, and for this one maybe I'm going to just change this to run over primitives. And now onto the attribute VOP node, we have this CD color attribute, and let me connect this. And in here I can play around with the 3D frequency to play around with my noise pattern, amplitude. Now let's use this as our in the poly extrude node. So let's connect this, and onto the poly extrude I'm going to change this. Right now it is expecting a Z scale attribute. So what we can do, we can either create a Z scale attribute by using a bind export node, because you know we can use the bind export to export our attributes. So in here I can just type the name. I can say please create a Z scale attribute, and to the values, this time we are going to use this input to set the values. So previously we have used this parameter to set our value, but right now I want to use this as an input. So let's connect this, And now we should have an a z-scale attribute. If I press and hold on middle mouse button, and here as you can see we have the z-scale attribute, poly extrude, and that is enable. And we also need to play around with this parameter because this will become as an a multiplier. So which means we need to adjust this, and we also need to divide our geometry into separate components. So let's change this into individual elements. And here we have the extrusion. Right now the extrusion is a bit extreme, so let's lower down this z-scale value. And here as you can see we have this noise based extrusion. I can dive inside the attribute VOP node, and to the anti-alias noise I can play around with the amplitude. That will also adjust the extrusion length because that's the amplitude. I can also play around with the frequency to create more high frequency or low frequency noise. And by creating the low frequency noise we have these bigger patches, and by high frequency we have these lot of these smaller patches. And we can also export these parameter as well. And right now here as you can see, if I were to, let's say, play around with the noise parameter, every time I need to dive inside this attribute VOP node, I need to find the node. Okay, that is the anti-alias noise, and I need to find the parameter to adjust. I can also expose these parameter as well. So if I were to go back, if I want to adjust the settings from here at this level, I can also export these parameter. So let's go into the attribute VOP node, and the way we can do this is by, if you come over here onto this, let's say I want to expose this 3D frequency, and here we have the input for the frequency. I can just press the middle mouse button onto this input, and in here we have this option called promote parameter. So let's click on it, and here as you can see we have this dot, this bigger cylinder, and that means that there we have a parameter node connected into it. I can just click on it and double click to expose this, and now here as you can see by double clicking on this cylinder, here we have this parameter node assigned. I can bring up the parameter, and what that will do, it will expose this parameter onto this level. So which means I can go back, and here as you can see we have the frequency parameter exposed in here. I can dive inside, and in here I can expose any of these parameters. Let's say I want to expose the amplitude, so just come over here onto the amplitude, press and hold the middle mouse button and click on promote parameter. That will promote this parameter onto this higher level. And now I can just play around with these settings in here at this level. And if we dive inside, and here as you can see I am using the P as an A import, and I am writing this as an A CD as well as an A Z scale. I can just go into the poly extrude, and I can say please not use the Z scale but use the CD. So I can do so by typing the name. So let's type the CD, capital C, lowercase t, and here as you can see we have result all the same, which means I can dive inside and I don't need this Z scale attribute. So let's delete this, and here as you can see we still get this extrusion, because we are no longer using the Z scale attribute, but we are using the CD to set out these extrusion. And now let's dive inside the attribute VOP node, and here as you can see I am importing the P and outputting them into CD by using the bind node to import the attribute and bind export to write out my CD. And if you remember, if I go back and if I were to create an attribute VOP node, so let me lay down another attribute VOP node, and if I dive inside, and here as you can see every time you create attribute VOP node you will be greeted with these two nodes. Okay, we have this geometry VOP global and we have the geometry VOP output. What are these guys? So these guys are there for your, in here we have these, basically we have this bind node inside of them, and here as you can see we have this digital asset, so which means I can double click to type inside. So basically what that is doing, it's just creating multiple bind node, so which means that I can always have access to P, which means the position, and we also have this V, which means the velocity, force, and all of these things. So these attributes, for example the V and force, does not necessarily need to have present into our input geometry. It's just that if they are present, I do not need to create a bind node and type the attribute. I have a shortcut for importing all of these attributes. So these are the preset shortcuts. For example, we have the P present in here. I have the CD and N for the normal, and we have the UV and time and all of these attributes. And onto the output we have this, we can write this back to P as a position. I can write this as an V, velocity, force, CD, and N. So we have these attributes, I can write them in here. So these are basically the bind export nodes. And here you can see the bind export, we have lot less export, but we have lot more import. And that is because not all of the attributes are writable, which means some of them are read only. For example, here we have the ptnum. Ptnum store the current point number. If I go into the geometry spreadsheet, let me go back because it's an empty. And here as you can see, ptnum is this attribute. Here we have the point number 0, 1, 2, 3. And here as you can see, that is the point number. I can go into the scene view and let me enable my point number display. If I click on it, here as you can see, we have these unique point numbers. I have the point number 845. So these numbers are basically stored in the ptnum attribute. And here we have the ptnum. So that is the attribute that store all of these numbers, point numbers. So it is not a writable, it's a read only attribute. And I also have the primnum, which is these primitive numbers. And I also have numpt, which means the total number of points, number of primitives, and number of vertex. And I also have the time, which store the current time and the current frame number. So not all of these attributes are writable, they are read only. And here we have these attributes that are writable, position, velocity, and all of them. These are basically commonly used attributes. So which means I can go back onto the attribute VOP node, and here as you can see, we have created the bind to import the P and bind export to set as an ACD, which means I can just remove this and I can bring back my geometry VOP global. So in here I'm going to say geometry VOP global parameter. So if you type and add this, and here as you can see, we have this node back. And same way I can in here create our geometry VOP output. So let me add this geometry VOP output. I can use these default guys to import my position. Here we have the P already there, which means I just need to connect this. And onto the noise, I can just output this as an ACD. And now if I go back and view the result, and here as you can see, we have our attribute VOP working correctly, and we have the extrusion. Let me remove this and onto the attribute VOP node, and I can animate the noise, and I can animate this by this time parameter. The time will store our current time if I enable my play bar. And here as you can see, we have this playback animation. I can hit play, and here as you can see, that is the frame number, and it is, and at the frame number, let's say 56, we have a certain time value. So that is actually stored in this variable, which means I can go into the anti-alias noise, and I can, let's say, play around with the 3D offset. and we have this offset parameter. So I can connect the offset parameter onto my this time to animate my offset over time, which means if I were to play this onto the play bar, hit play button, and here as you can see we have our animated noise. Let me stop this by clicking this button, and right now our animation is not in real time. It is playing as fast as it can. I can change this to real-time playback by clicking on this clock button, and here as you can see we have this real-time option. Let's enable this, and now our animation should run at real time, which means at the 24 fps. So that is the real-time animation. And I can also animate my offset with my current frame number. Right now I'm using the time. I can also put the frame number. Frame number that is the variable that actually store our current frame number. If I were to create an a point export node in here and maybe just plug this in here, and now we are creating this POM attribute, and I can just go back. I don't need to rename this. Go into the geometry spreadsheet and it should be a primitive. So let's go into the primitive, and here you can see POM, we have the value of 21 because we are at the 21 frame. If I were to change this, let's say 47, and here you can see our attribute, this has been also changed to 47. I can play, and here as you can see, as my timeline is progressing, we have this POM progressing. So that is the attribute basically that store the current frame number. Let me remove this one also, remove this. I can put the frame number in here as an animation onto the offset, and now I should get the extrusion. But right now the animation is very chaotic because our values has been changing drastically. So that is why we have this very chaotic animation. And if I were to create all of these setup by writing my own code, I can do so onto the attribute wrangle. And to actually write this, we need to take care of the syntax, all of these for importing the attribute and writing out the attribute. And we have this noise, and for that let's go into the attribute wrangle. First we need to, let's say, create a noise in here. So creating the noise, we have some functions. So we can take a look at all of the VEX function. If we go into the help and contents, and if I enable this, that will bring up my this Houdini help page. I can go down here onto this reference menu, and in here I can see a section for the VEX. Let's click on it, and that is a VEX language reference. Let me make this pin a bit bigger, and down here we have another reference tab, and in here we can see VEX functions. Let's click on it, and here we have the list of all of the available functions that we can use. So for example, because we are working with noise, I can just click on here and filter this by noise, and here as you can see we have all of these filter, and here we also have a filter for the noise. Let's click on it, and here we have all of these different types of noise that you can create. For example, if I go into the A noise, let's click on it. So that will generate an alligator noise, and we have the syntax. There is several way of calling this function. So first we have the data type, we have this float data type, and we just need to define this anti-alias noise and type all of them. Let me close this, and in here if I type A noise, and here as you can see the function appears now in the braces. I need to define all of the parameter which represent these anti-alias noise parameter, the frequency and position, and write all of my this whole setup in the VEX code, and that will create a much more complicated way of writing the same function, but it's actually easier to understand. So whenever we are creating a very complex scene whenever I'm working, let's say writing in a complex script, I have nodes and nodes. This node editor will get quite messy pretty easily. To actually avoid this, I can go into the attribute wrangle and I need to type all of these things in as an a VEX code, and it will be much more easier to understand because it will be like reading as an a book. Here I can just read, I'm creating noise in here and doing all of these things. So it will be easier if you are working with much more complicated scene, creating complicated script. So it's better to write your own VEX code. But if I am creating a simple scene, creating a simple noises, I always use the attribute VOP node because it's just much easier to just lay down the anti-alias noise and play around with these parameter and be done with it. And in this course, I will try to avoid using this attribute wrangle to write VEX code because it's a beginner level course. So I will try to use this attribute wrangle as minimum as possible.